in Ahmedabad High School and the Junior College. Welcome to the series of the lectures of Intermediate First Year Chemistry. We have started our discussion with our important topic, that is atomic structure. In the previous class, we discussed the basic things such as the consequence of atomic structure, Bohr's atomic model. That is, we discussed what is the quantum numbers, what are the different quantum numbers, right, to describe an atom and its behavior, right. In order to continue this thing, we are going to discuss the different shapes of an orbitals, okay, the different shapes of an orbitals or shape of orbitals. This is what we are going to discuss in our session, okay. In the last thing, there are two things, that is, one is a monadic quantum number and one more is azimuthal quantum number. What information does it give? That is giving information about the shape of an orbit and the orientation of an electron in a space. What is the space? What is the shape of an orbital and in what way is it being oriented? Is it clear? Based on that, this is the value of L, right? What is this L? Azimuthal quantum number, right? What information does it give? We saw that based on that we can define the shape of an orbital. That is, this is being exactly in this origin position, okay. Then the electron will be somewhere within this sphere, okay. Its position is in this place, which means the electron, or else we can find the probability of electron within this space, okay. This is how he described the three-dimensional space of an orbital. That is, if my origin is at the center, then it can have a spherical in shape, okay, spherical shape in which we can find the electron in that, okay. Is it clear? This is how we can define the shape of an s orbital is spherical. And the second, that is p orbital. P orbital, what is the value of L? L is 1, okay. Then what is the value of ml? ml can have the values of -1, 0 and +1. Here also we can define it as ml as 0. It can have only one value, only one sphere, okay. Now see here, here we can have the values at three different things, that is at -1, 1 and at origin, okay, which means it can have a sphere at -1 and +1, okay. Then the shape we can define it as dumbbell, okay. Is it clear? This is how, which means p orbital can have three different sides, that is, it can have along x direction or along y axis or along z axis, which means it can have how many electrons? It can have 6 electrons, in which each orbital can have maximum of 2 electrons. We discussed there, right, in spin quantum number, right. Each orbital can have 2 electrons, which means p orbital can have 3 orbitals, which means it can have 6 electrons. Is it clear? Each orbital 2 electrons, we can have 6 electrons. Now see here, this is one orbital, that is, it is along x axis. We define it as px or simply 2px. Since the p starts from here, we can define that. Here also it starts with, it is along y axis, therefore it is 2py, here it is 2pz, since it is along z axis, okay. Similarly, when it comes to d orbital, its Lk is nothing but 2, right. What are the ml values? It starts from -2, -1, 0, +1 and +2, okay. Is it clear? Since it have 5 d orbitals, how many electrons it can have? It can have 10 electrons, okay. 5 different d orbitals. What are those? One thing is between x and y, one is between y and z, one is between z and x. After rotating, it can have x square minus y square. That is, this is in between x y plane, okay. And after that, finally it is dz square. This is one along the other, which means on the same z, one after the other. Since we can't define it, we have defined it, we have drawn it like this, 2 circles. It represents that one on the back side of other, okay. That is nothing but dz square. Is it clear? Since it have 2 dumbbells, the shape of this is double dumbbell. Okay, at least try to remember the basic thing, that is the shape of an s orbital is spherical in shape, that is one sphere. The shape of p orbital is dumbbell. And one more thing, for s orbital how many electrons it can accommodate? It can accommodate 2 electrons and 1 orbital and spherical in shape. When it comes to p orbital, it has how many? 3 orbitals. I mean, those are simply called as degenerate orbitals. Okay, it can have 3 degenerate orbitals and can have accommodate 6 electrons in it, and the shape of an orbital is dumbbell, right? When it comes to d orbital, it can accommodate 10 electrons with 5 degenerate orbitals, right? And the shape of those orbitals is double dumbbell. Is it right? Hope you understood till here. Let us move on to the next topic, right? Did you understand the different shapes? Is it clear? The shape of an orbital, we can define it as, or orbital is defined as the finding an electron in the space. Okay, the probability of finding an electron in a space around the nucleus. Then what is the probability that not finding an electron in the space? That is nothing but a node. Okay, there can be a node, right? We have different shapes, for such as p orbital can have a dumbbell shape. Other than those dumbbell shape, what about the remaining space? That remaining space or that particular points are called as nodes. Okay, or else you can find the node at which the space between the two dumbbells, that particular point can call as a node, which is defined as the point at which there is no probability of finding an electron, right? How many nodes we can have? That is, there is a formula, that is number of nodes in an atom can be n minus L minus 1. Okay, where n is principal quantum number, L is azimuthal quantum number, right? And a nodal plane is nothing but our L. What is nodal plane? What is nodal plane? The plane in which we cannot find an electron, or the plane in which the probability of finding an electron is 0. Okay, did you understand? Fine. The next topic we are going to discuss is Aufbau principle. Aufbau principle, it defines the order in which the electron is to be filled in an atom, right? Aufbau defines that an electron always fills the degenerate orbitals in the order of increasing order of n plus L values. Is it clear? Did you understand? Right? That is, the order he gives it is 1s less than 2s less than 2p, 3s 3p and 4s 3d. How did he define? Shall we check once? Now see here, for 1s orbital, what is the value of n? 1s. Okay, see here, if you don't know how to write that, remember this order, n L power x. What is n here? N is Bohr's quantum number, that is principal quantum number, which is number of electrons. What is this L? L defines the shape, that is, for s orbital it is 0, for p orbital it is 1, right, for d orbital it is 2, and for f orbital it is 3. Then now check here, if we compare with this, what is the value of n here? N is 1, L, what is the L value for s orbital? It is 0. If you add, it is 1. Okay, now let us check for 2s. 2s. Then n is 2, L is 1. L is 1 or 0? L is 0 here. L is 0. Then what is the value of n plus L? 2 plus 0 is 2. Right? Let us check for 2p. 2p. What is n? 2. What is L? What is the value of L for p? That is 1. What is n plus L now? 3. Right? Is it increasing? 0. I mean 1, 2, 3. Here n plus L is 1, here n plus L is 2, here n plus L is 3. Right? Which means it is increasing in the order of n plus L. Is it clear? This is how we will fill the electrons. First the electron will fill in the 1s orbital, then 2s orbital, then 2p, then 3s, then 3p, 4s and 3d. Right? And not only that, to understand this we can, there are a few theories that the distance of an orbital from the nucleus is defined as like this. Okay? If this is 1s, then the second will be 2s. If this is 1s orbital, then the second orbital will have a slight energy more than the first orbital. right? If it comes to p orbital, it will be going on increasing. Is it clear? From that theory only Hofbauer can define that electron is being filled in the degenerate orbitals in an increasing order of n plus L. Okay, is it clear? Based on that, there is one more scientist named as Molar. He developed a chart. There is a chart. There is a whole a chart describing all the orbitals, which means the first electron fills in a 1s orbital, then the second electron fills in 2s orbital, then the next set of electrons will fill in the 2p orbitals. Once again, remember how many electrons do we have in a single degenerate orbital? We have 2 electrons in a single degenerate orbitals. How many degenerate orbitals can we have in s orbital? 1. How many degenerate orbitals can we have in p orbital? We can have it as 3. Okay. Then in d orbital we can have 5 degenerate orbitals. Similarly, in f orbital we can have 7 degenerate orbitals. Is it clear? That means how many electrons we can fill in as? We can fill 2 electrons. If it is p, it is 6. If it is d, it is 10. If it is f, it is 14. Is it clear? Right? This is a molar diagram. Based on this also you can remember. Okay, that is 1s, then 2s, then 2p, 3s, then 3p, 4s, then 3d, 4p, 5s, like that. Okay, is it clear about Hofbauer's principle? Is it right? Now let us move on to the next theory. The next is Pauli's exclusion principle. Who is this Pauli? Right? Pauli exclusion principle, he defines that no 2 electrons will have all same quantum numbers. Did you understand? No 2 electrons will have all same quantum numbers. Why, how, and everything. Let's see. Let us take an example of some element such as hydrogen. You know that its configuration is 1s1. Or else let us have helium. It is 1s2. Okay, it has 2 electrons in it, right? Then shall we write the NLMS values for this? Let's write. What's the value of n? Let us have 2 electrons, right? 1s2, it has 2 electrons in its orbital, right? Let us write it for both. The n value for first electron is 1, second electron is also 1, right? L value, since it is s orbital, obviously L value for s orbital is 0, right? What is the value of m? There is only one value, therefore it can have 1 or it can have 0. The total value is 0. It has only one space. When it comes to spin, what is the spin for this? It is plus half. What is the spin for this? It is minus half. Is it clear? If it is a degenerate orbital, how many electrons does it have? It has 2 electrons, which means do we have all 4 quantum numbers same? Do we have? For first electron, we have n as 1, L as 0, m as 1, s as plus half. For the second electron, we have n is 1, L is 0, m is 1, s is minus half. Right? Do we have all 4 same? No. Pauli explains that no 2 electrons in an orbital can have all 4 equal quantum numbers. At least there will be one different quantum number. Is it clear? Did you understand? That is a simple theory he wants to explain. And we can also generalize that the maximum number of electrons in a shell can be 2n square, where n is principal quantum number, right? Is it clear? He generalizes that the maximum number of electron in any shell can be 2n square, right? Is it clear? Did you understand? Where n is number of orbit or nothing but the principal quantum number. Is it clear? And the next theory we have to discuss is Hund's rule. What is this Hund's rule? Why is this important? What is it? That is, an electron pairing will take place only after all the available degenerate orbitals are at least filled with 1 electron each. Is it clear? For example, let us have an example of nitrogen. What is the atomic number of nitrogen? 7. Right? How is 7 filled? 7 is filled in which way? That is 1s2, 2s2, 2p3. Isn't it? Which means 2s2, if we take as 1s, it will have 2 electrons, 2s 2 electrons. When it comes to p, 3 electrons are left. Which means if the first electron is filled in the 2px orbital, then the second electron should be filled in the next orbital and the third electron fills like this. Right? Until and unless these 3 are filled, then only the pairing happens. Is it clear? Hope you understood. How to write this configuration? If you see here, we know that the order is 1s, 2s, 2p, 3s, 3p and so on. Right? How many electrons can an s orbital accommodate? It can accommodate 2 electrons in it, which means nitrogen has 7 electrons with it. 7 electrons, that is 2 will be filled here. Again, for example, let me talk. There are 2 places here for 1s. There are 2 places for 2s. Then there are 6 places for 2p. 6 places. Okay, I have 7 electrons with me. I will fill 1, 2, done. 3, 4. Left are 3, 5, 6, 7. Is it clear? Which means can I write it as 1s2, 2s2, 2p3. Right? But how are these 3 electrons are being filled? These 3 electrons are being filled with 1 electron each in each orbital. Okay, what happens if, for example, if I take oxygen, what happens if my oxygen is filled here? Or else what happens if it is fluorine? Right? What about this? Is it fully filled or half filled? Why it is needed? Because the thing it requires is the stability. Here the main constraint comes. What is the stability? When an atom is said to be stable. An atom is said to be stable only when each and every degenerate orbital of an atom is either half filled or full filled. Okay, see here, for example, if we consider as nitrogen, initially it was half filled. Was it be stable? Yes, it is stable because it is half filled, right? Because the energy is being distributed equally, right? That is actually called as symmetrical distribution. Okay, these constraints come with a typical question such as if it is carbon. What is the configuration? What is the atomic number of carbon? It is 6. What is its configuration? 1s2, 2s2, 2p2. Right? Which means in the first orbital, I mean s orbital, it has 2 electrons. In s orbital, it has 2 electrons. And in p orbital, it has only 2 electrons. Right? What about the third orbital? Which means when if the energy is given to this orbital, the electron in the 2s orbital will jump and settle in the 2pz. Okay, then the configuration becomes as 1s2, 2s2, 2p2, or else here it will become 2p1, here it is 2p3. This is half filled, this is half filled, therefore we can consider it to be stable. Actually, we cannot explain this carbon example. There are few other elements such as copper, chromium. Is it right? Such kind of elements can be modulated. Right? How to do and everything. Is it clear? Is it clear? This is how the stability is maintained. Right? The stability, this is a kind of symmetrical distribution. And there is one more chance that if there are these many electrons, these all have same spin. Right? These all have same kind of energy, or else these are in the same orbital with the same spin. Then they can exchange their energy. Right? This can either go to this or this can either go to that. Okay? They themselves can exchange the energy. Right? Which means, for example, this can jump to this or this can jump to this. Right? By jumping, there is a chance of releasing a minute energy, or there is a kind of difference in their energies. That difference or that energy is called as exchange energy. Remember, that is a simple thing, right? Which means stability can be obtained only by symmetrical distribution or by exchanging the energy between the same degenerate orbital. Is it clear? By this different topics, we are at the end of structure of atom. Okay, what are the different topics we have discussed? We have started with the subatomic particles, we have discussed a few things, then we have entered into the different atomic models, that is Thomson's atomic model, Rutherford atomic model and the Bohr's atomic model. And the basic theory is to understand the atomic structure, such as Planck's quantum theory, what happens when an electron or a photon is being incident on an atom, right? What happens when an atom is being placed in electromagnetic field? No one could explain that, right? Bohr could not explain that Stark effect and the Zeeman effect, right? Based on the Bohr's theory, other scientists such as de Broglie, Heisenberg, they gave the few theories such as de Broglie hypothesis, that is dual nature of matter, then uncertainty principle, clear? And one more thing is quantum mechanical model. How did it start? Who started it? Schrodinger equation, clear? And quantum numbers we have seen. And the next, the few theories such as Hund's principle, Pauli's exclusion principle, Aufbau's principle, right? And we have learned how to write an electron configuration. Then we have discussed about stability of an atom. Is it clear? With this kind of theory, we can discuss more and more concepts of how an atom behaves in the presence of another atom in the different fields. Okay. In the next session, we will start our discussion with the classification of elements and the periodic table. Okay. This is for today. This is the atomic structure. Okay. Hope everything is clear for you, right? Let us meet in the next session with a new topic, that is periodic classification. Okay.